order of operations. So first thing we got to talk about are exponents. So what we talk about with exponent, it represents repeated multiplication. So instead of writing something out like this, like a times a times a times a, we can write it as a to the fourth, and it means the same thing. It's just a simpler way of writing it. So a couple more vocab words. This a, whatever has the exponent, is called our base. And then this little number that we write at the top right corner is called our exponent or our power. One key thing, only that base is raised to the exponent. So it's only whatever's directly in front of that exponent. So some examples. So we're going to write out what these actually mean. So what this first one means is 5 times x times x times x. Notice this x is the base of the exponent 3, so it's that x that we write out 3 times. This next one, this whole thing is the base because it's parentheses. So what this means is 5x times 5x times 5x, because this whole thing has that exponent. So this next one, what this actually means is -1 times x squared, which is -1 times x times x. Notice there's no parentheses, so only this x is the base of that 2. That negative is, we leave it out front. This next one though, notice this whole thing is in parentheses, so we actually write it as -x times -x. So I want to point out the difference between this one and this one. This one, the negative's not included with the exponent. This one it is. Just like this one, that 5 is not included in the exponent, and this one it is. So we're going to practice simplifying now. So remember, what this means is -3 times itself 4 times. So -3 times 3 is 9, and then -3 times -3 is another 9. 9 times 9 is 81. So for this next one, even though it's a fraction, it works the same way. So it's this 2/3 times itself 3 times. 2 times 2 is 4. 4 times 2 is 8. And then we have 3 times 3, which is 9. 9 times 3 is 27. Now remember that negative's not in parentheses, so what this actually means is -1 times 5 squared, or -1 times 25, which is -25. This time that negative is included because of our parentheses. So we have -5 times -5 times -5. -5 times -5 is +25. Times that last -5 is -125. Alright, so now when we actually walk through the order of operations, first things first, we always want to do our grouping symbols first. These could be in parentheses, it could be in brackets. Sometimes we use a fraction bar. We can use absolute value, anything that's grouping some numbers together. After we've simplified our grouping symbols, we deal with our exponents, then multiplication and division. Key thing, we work from left to right. Multiplication and division, you can think of them as being on the same level or the same playing field. There isn't one more important than the other. You go left to right on the order that you see them. And then same thing with addition and subtraction, left to right. Addition doesn't always come before subtraction. It's whatever you see first in the problem. Alright, so going through these, notice we have grouping symbols in this first one. So we have to simplify whatever in the grouping symbols first. 5 minus 1 is 4, so we put that in our parentheses. And now we can move on to exponents. We move on to 4 cubed. 4 times 4 is 16. 16 times 4 is 64. Now we do our multiplication, so 3 plus 128, and we get 131. Now this next one, remember, it's all multiplication and division, so we go left to right. So even though a lot of people say multiplication first, the division comes first, and they're on the same level playing field, so the division comes first here. So 48 divided by 12 is 4, times 2 is 8. Alright, we want to do the same idea here. So notice there's no grouping symbol, so we start with our exponents. So we have 4 times 7 minus 6 squared is 36, divided by 3. We do our multiplication and division. So 4 times 7 is 28, minus 36 divided by 3 is 12, and then 28 minus 12 gives us our 16. This one, there are grouping symbols, so we start there. 8 squared plus 6, 14 minus 12 is 2. Next we do our exponents. 8 squared is 64. (64) plus 12, and 64 plus 12 is 76. Same idea, start with grouping symbols. 3 plus 4 is 7. 7 squared is 49. 49 minus 32 is 17. Start with our exponents since we don't have grouping symbols. 11 squared is 121. Now do multiplication or division, which we have multiplication. And then subtraction and addition is left to right, so 121 minus 56 is 65. 65 plus 2 is 67. On this one, notice we've got grouping symbols, and inside it there's going to be more than one thing going on. So once you're inside grouping symbols, you still want to hold to the same order of operations. So inside our grouping symbols, we still want to do that exponent first. So 3 squared is 9. And then still stay within our grouping symbols because we can still do more. And now we've gotten our grouping symbols as simplified as possible. We're left with division and addition. So we do our division first, and then our addition last. Alright, this is a case where I talked about how we can use the fraction bar as a grouping symbol. So what this is telling us is we need to get our numerator as simplified as possible and our denominator as simplified as possible, and then write it as a fraction and divide it. So one way of doing that is you can focus maybe just on the numerator or just on the denominator at first. So if we focus on the numerator, you want to do grouping symbols first, so 5 minus 2 is 3. Next we do exponents, so 3 squared is 9. 3 times 9 is 27. When we add our 7, we get to 34. Our denominator, no grouping symbols, there's multiplication and division, so we go left to right. 18 divided by 3 is 6. 6 times 3 is 18, minus 1 is 17. And now we've got to put them back as a fraction, so 34 over 17, which reduces down to 2.